That alarm always kind of scares me in the morning there when I wake up. So, hey, let's get it together here, people. We are in lesson number 2. We are generating equivalent expressions. All right, so with all this being said, is generating equivalent expressions is simply known in this phrase as simplify. This word simplify gets used a lot throughout your mathematical careers. For the most part, we have seen it with fractions. Hey, let's simplify. In other words, simplest form. But really this word simplify just gets used as, hey, let's clean things up. We're going to do anything we can to make it smaller. And here, we're going to use it by combining like terms. All right. So, first thing that we're looking at here is, in this first problem, it says, find the difference when 6h is subtracted from 2h minus 4. Now, subtracted from. We don't see this a lot, but subtracted from falls under the less than category, which means flip that order around. So this 2h minus 4 is first, and then minus the 6h comes next. So the rule here is we can only combine like terms. And like terms are terms that have the same variable and the same exponent. In other words, they look alike. All right. So in other words, this negative 6h is a like term with 2h because the h's are the exact same. This negative 4, not a like term. No h to go along with it. So I can only combine the like terms. So if I combine a 2h with a negative 6h, well, 2 minus 6h, negative 4h. The letter just comes along for the ride. And then I can't do anything with this 4. I do need to bring the subtraction sign along with it because it is negative. So yeah, negative 4h minus 4. This is what we refer to as standard form. We like the letters to come first and then just the plain old numbers to come last. So again, it's going to take, there's, our math grammar here. It takes a little bit of time to kind of get used to them. All right. Next one here, it says find the sum by aligning the expressions vertically. Okay, so one of the techniques that you can use here is actually by stacking the like terms right underneath each other. I'll be honest, not a big fan of it. Okay, not a big fan of it because it's just not how you're going to use it moving forward. I'd much rather you get into it now than have to switch techniques a year down the road. But we'll show you what they're after. They're saying, hey, take a 5a plus a 3b minus the 6c plus, and again, they're stacking the like terms, the b's under the b's, the c's under the c's. And now you can see it a little bit better. Negative 6c plus 13c, 7c. 3b, I know it looks like a 6 there a little bit, like a 36. Yeah, no, 3b minus a 4b, well, that's a negative 1b. And then 5a plus 2a, 7a. So there we go. Okay. So again, that's what they're after. But honestly, we don't. All right. We want you to get used to just going, hey, 5a and the 2a, 7a. 3b combined with a negative 4b, negative 1b. There you are. Negative 6c combined with the 13c. Hey, there's your 7c. So, again, we'd rather you do that, but, again, I think it's good to kind of see where it's coming from. All right. Whew! This is the one we got to watch for, and this is the one that's going to cause issues at the beginning for a lot of you. And I get it because it's going to take a little bit of time of getting used to it. But this is a subtraction sign. This subtraction sign goes with everyone that's inside the parentheses. So the big thing that we say here is to rewrite the problem. So I got a 2x plus a 3y minus a 4. This subtraction sign has to go with everyone. We use the phrase distribute the negative. So that negative sign needs to go everyone. So because it was a positive 5x, because that negative is getting distributed to it, it's a negative 5x. Because it's a positive 2, that subtraction, it is a minus 2. Now let's combine our like terms. 2x with the negative 5x, negative 3x. The 3y, the positive 3y, with the, I don't have any y's. Okay, bring them along for the ride. And then it's the -4 being combined with the -2. There's your -6. So again, it's very visual. I like to circle. I like to underline because that way it keeps me focused to what's going on. Certainly isn't required by law, but at the same time, if you find that it works for you, then use it. All right? Let's see here. Let's see. No, I'm not going to deal with you quite yet. I don't like you here either. Not to say that's not the case. Is there anyone else? No. Okay. All right. Well, hold on. Wait a second. I know. You thought we were done, right? No, I just wanted to kind of see what was ahead there. All right. Let's come down and let's look at these. Again, simplifying by combining like terms. We saw this before in the previous sentence. Plug in the variable given to check it. No, we're not going to ask you to do that. So here we go. 6x divided by 2x. All right. So 6 divided by our 2, we see our 3. Anything divided by itself. So it's an x divided by an x. 7 divided by 7. 12 divided by 12. J divided by j. Anything the same thing divided by itself is a 1. All right. So kind of what we say a lot of times is they knock each other out. Because it's just a 1. And if you multiply by a 1, it doesn't change. And if you divide by a 1, it does not change as well. You're out. Get it out of there. All right. So it's just a 3. That's it. All right. 8x divided by 2y. All right. Well, 8 divided by 2 is a 4. All right. But the x and the y, those aren't like terms. So they can't play. So the x is still there. The y is still there. Because it's a 4, if we think of 4 as a fraction, it's 4 over 1. So that's why the 4 goes up in the numerator. All right. 32xy divided by the 8y. All right. So we can see here the 32 divided by the 8 is our 4. There's no one for that x to play with. But as we said with the y, you're out. Hey, anything divided by itself is 1. Multiplied by a 1, divided by a 1 doesn't change things. So a lot of people like to just go ahead and get them out of here. So we got a 4x over 1. Anything divided by 1 is itself, so it's just a 4x. There's your simplified answer. I do want to go back up to one more in here because I thought we were going to see another problem regarding it. Let's come back to C that's here. Let me show you one last thing and then we'll be out of here, all right? I'm going to make it a very similar problem. In fact, we'll make it even lighter. 3x minus, and then let's go 4x minus 3y. And I'll show you what I'm talking about here. So we'll kind of add that in over here. So this is that whole distribute the negative. You have to recognize that there's a subtraction sign out in front, and it has to visit everyone inside there. It's your distributive property. So that negative sign, when it visits the 4x, makes it a negative 4x. When the subtraction sign visits the negative 3y, double negative, yes, it is a plus 3y that's there. And I'll bring down my 3x that's there. So that's the part we want to be careful about, is it doesn't make everything inside subtraction. The subtraction sign has to visit everyone. So sometimes what people end up doing, and there's nothing wrong with it. I'm going to kind of erase this stuff out of here. This might help you see things a little bit better. Technically, it's a -1 that's in front of it. And so now if you see your distributive property, -1 times 4x, there's your negative 4x. -1 times a negative 3y, there's your positive 3y. So again, if you like that better, hey, by all means, put that 1 in front of there. Distribute the negative, and again, we can do it by multiplying by -1. We can by just putting it into each sign that's there. Oh, clock is ticking. I told you just one more. All right, people, that's it. We're out of here. All right, cut me off. We'll see you later.